On the cubic function, we can start now here. On the cubic functions, we are having we start with finding the stationary points. How do we then find the stationary point before we can go to the standard equation or the standard formula? Stationary point of a function or of a cubic function. The cubic function standard equation here it's in this format. It can be the value of a, which is the coefficient of the highest exponent, and then which is a multiplied by x to the power of 3. The 3 is the highest degree, and then it can be plus or minus on the second part, which is b multiplied by x to the power of 2, x to the power of 2, and then again we will have plus or minus c multiplied by x, c multiplied by x, and then the last part we will have plus or minus d, which is the constant. Remember, when we derive the constant becomes 0. So remember that.
Yes.
The constant becomes 0. So when we derive, we start with the one that has x's. If they have a x, then that part of x we derive. Here there is x, the highest degree, to the power of 3. Here the x is to the power of 2. Here x is to the power of 1. Here it doesn't have x. It will be 0. So when we derive, we're going to say a multiplied by 3, which is the highest degree. We'll say a multiplied by 3 here. And then we will also say that exponent, which is 3, we minus it by 1. And then we go to the second part. We will have the exponent here, which is 2. We'll have 2 multiplied by b, which is the coefficient. And then we will say the exponent minus 1. And then we go to the third part. The third part here, it's cx. Then x, if it has thing, it means it's just to the power of 1. Then we will have 1 multiplied by the value, which is c. And the exponent, which is 1, we minus it by 1. And then d, which is the constant or just a value becomes 0. We will write 0 on itself. And then from there, we simplify what we have found so that we can now get to our derived equation. So in most cases, these equations have the name. They can say this name of equation it's fx, or they can say it's gx, or they can say it's hx. They can just label equation in anyhow. But then when they say derive it, you must know what to do, and then you must know how we do it. Now, I wanted to talk about this so that when we do the point of stationary points, then we understand what do we mean when we derive and when we say we do what and what. Okay, going further here. Going further here, they say that the first point, when we are drawing the graph, or looking for the maximum or the minimum, remember, the maximum and the minimum, they are part of the turning points on the graph. So to determine the maximum, you must firstly find the x value of a turning point and then substitute on the original equation, and then you will get the maximum. If you will get the minimum, you also have the endpoint, and then you substitute it on the original graph. This is the original graph, by the way. You substitute on the original graph, and then you'll either get maximum or minimum. And then those values of the function. Point number 2, it is useful to identify the turning points. These 2 points, or these points, are where the gradient of the graph is 0. Then we solve by saying that the first derivative of the function or of the graph. Remember here, the graph they have given graph in a form of fx. Like I said, they can give it the graph in a form of gx or hx or anyhow. Here they have given us the graph in a form of gx. So we say that the first principle, the first derivative, is equals to 0. So be careful. This one, they won't tell you, you do it. When they say find the turning points or find the maximum or find the stationary points of the graph or of the equation, what should come into your mind first is that the equation as it is, you write it down, and then what do? You first derive it. This is the origin that doesn't have a prime Then what do you do now? You start by solving it by saying that derive this whole thing. Like I said, the first part that you are going to derive has to be ax to the power of 3, you must derive the first part, then you derive the second part, and then you derive the third part, and then the fourth part, which is constant, you just write 0, it becomes 0. And then the whole equation, after you have derived it, you have to be equals to 0. It has to be equals to 0. I repeat again and again, it has to be equals to 0. Because if it comes to 0, it's going to be difficult for you. They even said here, it has to be equals to what? 0.
Okay.
And then after you substitute the value of x's that you found into the original equation. Remember, this is not the original equation. When we say f1, f1 is the first principle of it's the first derivative of the graph. So the graph we're looking for is f, not f1. It's f, or not the first derivative, it's f. So f is like this. So you will see the values, we'll see x on the graph. Firstly, we will find the 2 points, and then we substitute any of them here. Are we getting somewhere?
Yeah.
Okay, let's come back to screen. Okay, let me just find an example here so that we can talk about something.
Okay.
Let's say, for example, we are given the equation or the graph of f. Let's say is equals to x to the power of 3 minus 4x to the power of 2 minus 11x plus 30. This is the given equation of fx. So they said find the stationary point or the turning point of this. So when you find the turning point of this, what should you do? You must first find the first derivative. Now, the first derivative of this equation is equals to 0. You don't have to leave this thing behind. It's the thing that you should be doing. Okay, let's hope this one will work out. Okay, which means now we have to derive how many parts are here that you see. Part number 1, part number 2, part number 3, and part number 4. So here there are 4 parts. Can we see the screen, right?
Yes, I can see.
Good. Then now when we derive, say the first principle, or sorry, the first part or the derivative of this equation, we say here if there is nothing, the coefficient it means is 1. Don't forget that. And also on this, there is no exponent automatically is 1. Don't forget that, and don't ask questions or where do we get that. So we're changing now into an exponent. So we derive the first part. When we derive the first part, we will have 3 multiplied by 1, x to the power of 3 minus 1. Exponent, we minus it by 1. That is the first part, which means I'm done deriving this one. Then the second one, which is minus 4, I will say minus 4 multiplied by the exponent, which is 2. And then I rewrite x as it is, and then I rewrite exponent as it is, and then I minus the exponent by 1. Then I am done deriving the second part. I'm going to the third part. It's minus 11. Exponent is 1. I rewrite x and also its exponents, and then I minus by 1. Then I'm done deriving the third part. And then the fourth part, since it's a constant or a number, and then in the number, it becomes 0. The number itself, it's a rule of deriving. The number itself without x or being coefficient of x, it becomes 0.
There is a mistake I don't know. There by
Sorry?
4, you said minus 4 into 2. Is it 2 supposed to be there or 1?
Here is 2, right?
Yeah.
So the 2 multiply the coefficient of x. The exponent multiply the coefficient of the base. And the base is x. The coefficient is minus 4. That is why now here, on the first part, there was nothing to 1. The exponent now multiply the coefficient. That's why I'm having the same exponent, which is 3, multiplying. And then the same exponent on top there, I rewrite it, and then I minus it by 1.
Okay. And then it comes from negative 4 into 2.
Negative 4 times 2, yes.
Okay. So how
And
do we
then
get that 2? It is 4 by 2.
here I was deriving. Now I'm done deriving.
I don't
I
know
don't know
how
if
to put my equation together. I don't know if I'm asking it in the right way. I mean, how do we get to the point where we find that 2 in the second bracket?
initially the equation of fx is given is this one, right?
Yeah.
The first part is, or the first term on this equation is x to the power of 3. The exponent is 3, right?
Mm,
And then now when we derive, let me hide
mm,
this part. When we derive, we are going to say that the exponent multiply the coefficient. The coefficient
mm,
is 1. That is why here on the derivative, we are having the exponent, which is 3. The same 3 now comes and multiply the coefficient, which is 1.
mm,
And then the same exponent on the part of exponent, we minus it by 1.
mm,
Then on the second part, we are having minus 4x to the 2. Here the exponent is 2.
mm.
The exponent of x is 2.
Oh,
Remember, when we derive x. We don't derive any other thing, we derive x.
eh,
So we are going to say the exponent, which is 2, multiply the coefficient, which is minus 4. That is why we are having minus 1. So the minus 4 multiplied by 2. I put 2 in the bracket. And then I rewrite the exponent as it is with the base of x. You remember, you see now, this is the same as this one. So I will say the exponent minus it by,
mm,
and then continue further. We're having negative 11 x exponent of 1. Exponent here is 1. Then I will say 1 multiplied by negative 11, which is this part. And then the exponent is 1. And then I will say 1 as an exponent. I rewrite it here. It is. And then I say the exponent, I minus it by 1. Remember, I am deriving.
mm.
So I have derived. So the constant, which is that's the number without x, it becomes 0. That's why I put 0 here.
Okay. Yeah.
Then now we simplify. When we simplify, we will have 3x to the power of 2 minus 8x to the power of 1 minus 11. Remember, this one will give us x to the power of 1 minus 1 is 0. Anything to the power of 0 is 1.
Yeah.
Then this is our equation. And then they say our equation, it must be equals to 0.
0. And
So
then
if it's,
because it was in the power of 0.
sorry?
The last number 30, we are no longer having here down because
No,
of,
because it doesn't have an x. It's just a number.
oh,
We call it constant. If it doesn't have an x, it's a constant. When we derive, it becomes 0.
okay. Oh,
Yes. So now this 0 here, it comes from here. This is the
mm,
same 0 here. And then f1, or the first prime of 1, is this whole equation here. This
okay.
expression now, it becomes this. And then this 0 now becomes this one. And then we know that when they 0, we have to solve.
Mm,
So here we solve for x.
okay.
Do you still remember how we solve the x?
Yeah, I think I still remember.
Okay, let's solve together. The value of a is equals to 3. The value of b is equals to minus 8. The value of c is equals to minus 8. Remember, this is a quadratic equation now, because the highest degree is to the power of 2. No longer 3. It's no longer 3. It's to the power of 2.
Yeah.
So we can use the quadratic formula. Okay, then we found our local minimum and our local maximum. by just pointing out the x values of the turning point. They will tell us like I said, if something is the value of y is maximum than the second one, then it's maximum. And then the other one, if you call it, like for example, the first one you got negative, the second one you got positive, the value of y when you substitute on the original, and then the positive one is maximum, and then the negative one becomes the minimum. And then again, we will go to the point of inflection. The point of inflection is a point in which that the graph start to change shape. Remember, the graph, it's in a form of a cubic. Cubic meaning what? It's in this format. The graph is drawn from this point. It says if it comes from up going down, something like this, it curves, then it goes up, and then this is the point where the graph changes or changes the direction. And then example, let me use different color for that we can talk about it. Then it goes up to the maximum and then it comes down. So you see now, you see the two things again. Then the first one here, this one, this point where the graph has turned is the turning point. So, and then where the graph has turned on the second part is also the turning point. So the first one here, you can see what it's below compared to the second one. So the first one, this one represent the minimum. So this one will represent the minimum on the graph. It will represent the minimum. This one, it will represent the minimum, while this turning point here, it will represent the maximum.
Yeah.
And then the point of inflection, this is going to be our point of inflection. You see where the graph has started changing the shape to create a new shape. This is the point of inflection.
Okay.
And then the point of inflection, we say that the second derivative now becomes 0. If you remember the first derivative, you rewrite the first derivative and then you derive it again on the second time. And then when you derive it again on the second time, it becomes 0. Let me just bring back the screen here so that we can see how we derive the second part. Are we clear?
Yeah.
Okay, then with the first derivative, we had 3x squared minus 8x minus 11. That was the first derivative. Let me bring back the second screen. The second screen, here we are.
Okay.
Can you see it? Okay.
Yeah.
Now that was the first derivative. Now a bit for the second time. Second time, it means now we're going to put the two primes here, 1 and 2, second derivative. And then second derivative, they say is equals to 0. Remember, we're looking for the point of inflection of what? Of inflection. Now, on the point of inflection, if it's equals to second derivative is equals to 0, and then we are going to say that derive the first part and the second part, and the third part, which is that's the number. Remember, the number becomes what? It becomes 0. Are we clear?
Yes.
So we continuing. We'll have the coefficient of x squared, which is 3, and the exponent, which is 2. So which means we have to say the exponent multiply the coefficient. Then we will have the exponent multiplying the coefficient. We will have 3 multiplied by 2. And then we rewrite it as it is, which is x to the power of 2. And then the exponent, we minus it by 1. We derived the first part. Are we clear on that one?
Yeah.
Then we go to second part, which is minus 8. If there is nothing on the exponent of x, it means it's 1. We put 1. If there's nothing written, it means it's 1. Then we will have minus 8 by the exponent, which is 1. Then we rewrite it as it is, and then we say minus exponent minus 1. Then the third part, which is just a number which is constant. Remember, the constant becomes 0.
Okay.
And then we simplify. We will have 6x to the power of 1 minus 8. That's the remaining, because here we'll have x to the power of 1 minus 1. 1 minus 1 is 0. Anything to the power of 0 is 1. And we'll have minus 8 multiplied by 1 multiplied by 1, which is 8. Then the whole equation according to, this is the second derivative, and then the whole equation of second derivative according to the this rule, it must be equals to 0.
Okay.
So if it's equals to 0, and then we will have to say that solve for x. Simply here, since it's just like a straight line, we take the other value to the other side, which is minus 8. We multiply by negative on the other side, it becomes positive. And then we divide both sides by 6, then we will have 8x is equals to 8 over 6, simply, which is equals to 4 over 3. And that is the x value of point of inflection. And then how do we get the y value? We will take this equation and then we will substitute it on the original, which is 3, sorry, x to the power of 3. The first one where we have derived this one, that is the original.
Okay.
Yes, and then when you substitute this value of x on that original, you will get the value of y, and then that will become the point of inflection.
Okay.
Can we proceed?
Oh, ile mathomo lirao x to the power of 3 minus 4x squared minus 11.
Yes, that's the original. That's the
Oh,
original. When we want the y value, we always substitute to it. Yes.
Okay.
We continue to the finding the roots. Ne?
Yeah.
Can see
Yeah.
the screen, right?
Yes, I can see.
Okay, let's proceed. This part, we have exhausted this one. Then our point of inflection when we come back is this one, like I said. Then that coordinate will be this one. It will be this one. So every time, remember this shape the way I have drawn it. The green part is the one that will show you the minimum, and then the pink part will show you the maximum, and then the points that are red are the stationary points, which are the turning points, and then the other stationary point, which is the point of inflection, is this one. Actually, it's this one. It's the point of inflection within. So going further, we now find the roots. We can find the roots. But before we find the roots, let's talk about these two graphs. The graph I have drawn before there, it was when the value of the A is positive. Not positive, it's negative, which means it's less than 0. We can see, what do they mean if A is less than 0? They say the graph decreases, and then after it decreases, it goes up, increases, and then after it increases, it goes down and increase. Now let me just redraw the graph that I did here. Then in this manner, they say this one, they say the graph decreases. It means something that decrease comes from up going where? Going down, right?
Yeah.
Then this is the turning point here. And then they say after it decreases, they say it increases. Then this is the point where it increases, it turns, and then it goes up. When it goes up, it reaches the maximum point of being up. And then what does it do again? They say it decreases. Let's see if it decreases, then it comes back down again. You see what they're talking about? The graph decreases, and then it decreases. Sorry, it decreases and then increases, and then it will decrease again. Then that is when the value of R is negative or less than 0. What is that value of R? The value of R simply is just meaning the coefficient of x to the power of 3.
Yeah.
The coefficient of x to the power of 3, if that's where a becomes. If now it becomes negative number, this whole a, if it becomes negative number, then the graph is supposed to be drawn in this manner. That's the shape of the graph when you go and draw it. Are we clear on that one?
Can you please come again?
When they say that draw the graph and then the coefficient of x to the power of 3 3, it's negative number.
A.
Which means now the value of r is negative because the coefficient of x to the power of 3 is where the value of a is, if you remember.
Yeah.
If you remember coming back here, this is where the value of r is. So at that point where the value of a is, they say that if this part, it becomes the negative number. So if it becomes the negative number, the shape of the graph, it will change. How will it change? It will start by decreasing, which means it is thrown from the top going down.
Yeah.
And then after it decreases, it has to go 10. This is the turning point. This is the turning point. That it turns, comes from down, it goes up. That is when they say it increases here. And then after it comes up, that's the turning point. And then the graph has to be drawn from the top going downwards, which means now the graph is decreasing. It means now the coefficient of x to the power of 3 is a negative number. That's why I put negative a here.
Okay.
Good. Then the second part, which is a greater than 0, which means the value of a now is positive. What do they mean the value of a now is positive? Let's see if the value of a is positive. They say the graph increases and then it decreases and then it increases again. It automatically tells us or the graph is drawn from the bottom going up. From the bottom going up. That's when the graph increases and then it reached a certain point. After a certain point where it turns, the graph now will change the direction. It goes down, which means the graph is thrown from the top. It goes down. That is where the graph decreases. And then again, it's supposed to turn. When it turns, it doesn't turn going downwards, but it turns upwards. And when graph goes upwards, we say that the graph increases. And then it goes upwards in this manner. That is the graph that they are talking about. The graph increases and then decreases and then increases. It means the value of a now is positive.
Yeah.
The coefficient of x to the power of 3 is a positive number. X to the power of 3 is a positive number. So here is supposed to be a. If there's nothing, is 1. So here is a positive number. Like the example of what we just did now on the first one, this one. Here is just a. If it's a, it means something is positive. And the one we just did of 3, sorry, of x to the power of 3, and then we had no coefficient given, which means if nothing is given, it's 1. We rewrite 1. Are we clear on that one?
Yes, yes.
Good. Then the second part of it, we find the intercepts. Finding the intercept, it's quite challenging. But if we can move step by step, we will get together to it. They say the first part, for the y-intercept, you just say exactly where there is x, you put 0. And then in everything on x on that equation, you will put 0. Then punch on a calculator, it will give you the value of y. And then for the x-intercept, the first part, you start by finding where the value of x, when you substitute, it becomes 0. So here, that is where we all start to do it manually. We do it manually in the manner of, if we are given the equation, however the equation is given, we start by saying, let's substitute minus 3. We start by substituting minus 3, and then you see, if you substitute minus 3 on the whole equation, you see what does it gives you. If it doesn't gives you 0, you go to minus 2, you go to minus 2, and then you see what does the equation gives you. If it doesn't gives you 0, you go to minus 3. Sorry, you go to minus 1, then you substitute minus 1, you see where the equation gives you. So if it doesn't gives you 0 again, you put 0, and then you see what does the equation gives you. If it doesn't gives you 0, you put 1. Then after you have put 1, you put 2. After you put 2, you put 3. Then after you put 3, and then still doesn't gives, the equation doesn't gives you 0, then that is we go into the numbers with the commas. Let's say, for example, you can start with a number like 3 over 2. You can start with a number like 3 over 2, and then you can still go to the number like 1 over 2. You can still go to those same numbers in the negative form. Then, strictly, one of these numbers, when you substitute on the original equation of fx, no matter which one it is, it will just give you 0 exactly.
Okay.
Am I clear?
Mm.
Okay, let's rewrite the same equation as it is, which was fx is equals to x raised power of 4x squared, then minus 11x plus 30. Okay, let's look at this equation and then do all these principles. And then when you get one of those equations, they say that now it becomes the factor, which means now you put it in the brackets in a form of a bracket. Okay, the way this one, they say solve for x. Like I said, by substituting minus 3 and see if it doesn't give you minus 2, minus 1, 0, 1, 2, 3. If it doesn't give you, subtract over 2, minus 1 over 2, substitute 1 over 2, substitute positive 3 over 2. It's supposed to give you 0 when you substitute this. The whole equation. Let's start with the 0. When I start substituting x is 0, let's if we put 0 here, we put 0 here, we put 0 here, the whole equation is going to be equals to 30. So which means the value of y, if x is equals to 0, the value of y is equals to 30. So which is our y intercept. The first intercept, when they said the y-intercept, you substitute x is equal to 0, and then you get y. Then this is the value of y. That was the y-intercept. Y-intercept. Now, on the x-intercept is different. On the x-intercept, you must substitute all of this until you get negative. So until you get this thing, all of it like this becomes 0. And you cannot do it in all the 3. And the x values that you will get here, they must be 3. It has to be a multiplied by the x value number 1, which is root 1, and then x and then root number 2, and then x and then root number 3. You must have x number 1 and x number 2 and then x number 3. If a is given on our coefficient here, a is 1. So which means here automatically is 1. Our equation can be written in this form. Now let's minus 3 on this equation and see how much we get. Let's do it together. When we substitute minus 3 here, we will get minus 3 cube, which will give us minus 27. And then minus 3 here, minus 3 squared will give us 9. 9 multiplied by minus 4, which is equals to minus 36. When we put minus 3 here, we'll get minus 3 multiplied by 11, which will give us positive 33, and then plus 33. Since we don't have calculator, we can do it manually. Then this one plus this one is going to be something like 63. And then this one plus this one, because they are negative both sides, is like they are plusing, but they will end up being negative. And then we will get something like also 63, if I'm not wrong.
Mm.
Are we clear? So
Yes,
in future, we'll have negative 63 plus 63, which becomes what?
0.
0. So which means our factor now is x plus 3. This is our factor, x plus 3. Why? Because we have substituted minus 3. If we were substituted 3, it was going to be x minus 3. How so? Because when we solve for x here, we're going to say x minus 3 is equals to 0, then x is equals to 3. So in our case, we have substituted minus 3. So when we have to solve the value of x there, we are going to say the value of x, we will take this plus 3 to the other side of the equation side, which will give us negative. Then we'll have x is equal to minus 3. That is why now we put it in the brackets as x plus 3. We're no longer putting it as x is equals to 3, because now when we put 3 on x, when we have to find 3, we're gonna get the wrong answer. So now we put it as x plus 3 in the bracket as our common factor. Are we clear?
Yeah.
So which means now on our equation, the way it is, we have the first part. The first part now is no longer x minus r, but is x into bracket plus 3. So we are left with the following twos. So how do we go around with this one? We have to now create the equation. We have to create the equation now with the remaining part, comparing this one with this one. Are we clear?
Yeah.
So with this one, we can use the synthetic method or we can use the long division method, but I would prefer that let's use this one so that it's gonna be easy and quick. We draw up a box, and then up here, we put our factor, which is minus 3. And then up here in the first box, we put the coefficient of every, the coefficient of every. The coefficient of this one here is 1, we put 1. The coefficient of this one is minus 4, put minus 4. The coefficient of this one is minus 11. The coefficient of this number is just 30 as it is. Are we clear on that one?
Now I'm in the other world now.
But then coming to this far, again, we have our factor is minus 3, right?
Mm.
And then we want our equation to be in this form: x minus r1, x minus r2, x minus r3, all of them in the brackets. Unfortunately, we only got the first one, which is x plus 3. Now we are remaining with the remaining 2. We must then find the value in here of this r and also the value in here of this r.
Okay. Okay. Yeah. Okay. Yeah. Now I can see.
Are we clear?
Mm.
You're writing them down.
Yes, I did.
Okay. When I in your high school, which method were you using?
If I can tell you that I can't remember. It's like 14 years back.
Because there is this one of a long division method. It's also
Can you please tell
applicable.
me that one? Maybe I can.
Sorry, it's the same procedure. It's the same procedure. It's just that we,
Okay.
I will just explain right now. We have to start with the one that can be. Because for my case, I did the synthetic one of not using the table. It was the one we assume the values. We have to assume the values.
Mm.
Then when we assume the values, we have to figure out the second equation and then we solve it. So with this one of a table, it's just gonna be more privilege. Do this one because the method, when I compare with the two methods, this one it's more simple.
Okay.
Because there's the first one of long division, the second one you have to find or your own using, we call them the factor theorem. Then this one they call it the synthetic division. Now you will have to put your factor outside as it is. Remember the first one we got, it was x plus 3, and then when we got x plus 3, when we substituted minus 3 on the equation. Are we together on this one?
X plus 3, and then we do what?
X plus 3 is our factor. as we
Yeah,
write
yeah.
in the brackets in this way.
Yes,
But
yes.
when we substitute on the equation, we are substituting minus 3.
Okay.
Then now here on this table, your table has to be 4 by 3. 4
Mm.
this side, 3 this side. And then you write the coefficient of every or the numbers only. You don't take the exponents. You don't put the
Mm.
x's. You just write the numbers down as they are.
Mm.
And then the first block, which is this one after the one you this one, you skip this one. You skip this one. You don't do anything on it. Are we clear on this one?
Yes.
Then when you skip this one, you bring down the first number, which is 1 on our case. Then I will bring down 1 here. I will just write 1 as it is.
Okay.
Are we on the same?
Yes.
And then how do I going to work with this one? I'm going to say that my factor multiply by the same number that I have put here. What is the value of my factor?
It is x plus 3.
No. X plus 3 is a factor. What is the value of the factor? The
Oh,
value of the factor is minus 3. Here it is.
okay.
So we will say that the factor multiplied by this number that is here. How much do we get when we say minus 3 multiplied by 1? We get minus 3. Then we will write it underneath or after the first box that we ignored. We will write it this part.
Mm.
Are we clear?
Yes.
And then after we add the two numbers, this one on top and this one at the bottom, we add them.
Okay.
So when we add them, we will have minus 4 minus plus minus 3, which will gives us minus 7 on a calculator when we add them.
Yeah. Okay.
Are we clear?
Yes.
And then the second part on it, what do? We'll say the same is minus
3.
minus 3, the same factor which is minus 3. Now it multiplies what? It multiplies the same number that we got here,
Yes.
which is what? Minus 7, right?
Mm.
Then it has to give us the number in this block.
It is 21.
Yes, plus 21, correct.
Okay.
Then what do we do with minus 11 and 21 to get the number in this block?
Okay, and then we go for minus 11 plus minus 21, which is going to give us 11.
We add them. Don't forget that we must add.
Yeah.
We will say,
Oh, then the other one is positive and the other one is negative. Are they going to?
Yes. We will say
Okay.
negative 11 plus 21.
Which is
Going to give us 10.
10. Okay.
When we punch on a calculator. And
Yeah.
sorry, can you tell me the last step, please, if you get to understand this method, the number that we will put here.
Negative 3 times 10, which is going to be negative 30.
Negative 30. And then what do we do to get the last block?
And then positive 30 plus negative 30, which is going to give us 0.
0. So now you see the last block at the corner, it must always gives you 0 if now the equation or if the graph has the other intercept.
Yeah.
So now what are we left with? We are left with 1, minus 7, and 10.
Okay. Yeah.
Then you must be careful on this one because now we rearrange. Are we clear?
Yeah.
Now, this one here, it will be the coefficient of x squared.
Okay.
And then this minus 7 here, it will be the coefficient of x.
Okay.
And then this 10 here, it will be the constant. I will just put C. It will be the last number, which is the constant.
Yeah.
Quickly.
Yeah.
That means our equation now is going to be in what way? Can you rewrite our equation? It's going to be 1x to the power of 2 minus 7x plus 10. This is our equation. You see that? Hello? Hey, am I still in the meeting here? Soon. Okay, then if that's the case, I can't see you being active. Okay, we will take the equation as it is, then we equate it to 0. Then we solve for x. And when we solve for x here, we put it on a quadratic equation. We will have something like x minus 2 minus 5. Then our x will be equals to 2 or 5. Then I will put my x, or I'll just take the way they are, x minus 2, then x minus 5. I don't know if you can still hear me or talk, but this is how we end up on it. Then we will have root number 1 is filled, root number 2 is filled, root number 3 is filled. Then our intercepts on this equation is x minus, so this x is equals to minus 3, and x is equals to 2, and x is equals to 5. Then you found the roots. Then after you have found the roots, oh, she flew away. Let's draw the graph. Let's draw the graph. The way of drawing the graph. Now we will draw the graph in this manner. We will plot our points here. Our x is minus 3 here. Our x is 2 here. Our x is 5 here. Then the value of r is equals to 1, which is positive. Then our graph will be drawn from coming down, going up. It will increase, decrease, and it increase. So which means the turning point value is somewhere in between here and also here. Then the graph will have to go increase and then decrease and then increase. That is the graph drawn to this one. Thank you much. We'll see you next time.